Looking at quadratic models, on our example 1, Lacey has 400 yards of fencing and wishes to enclose a rectangular area. Express the area A of the rectangle as a function of the width W of the rectangle. Okay, so they're asking us to write a function. So what does that mean? We're going to be writing an equation. Specifically about what?
W.
The area of what?
Rectangle.
A rectangle. Let's draw a rectangle. You have a rectangle. Okay. They gave us 400, which is a nice number, but if you have 400 yards of fencing, is that an area number? No, fencing goes around. So what do we call it when it goes around?
Perimeter.
Perimeter. All right, so in here we'll write P equals 400. We'll go ahead and say W, W, L, L. So based on that picture, what would an equation for our perimeter be?
2L plus 2 400.
Agreed. 2L plus 2W equals 400. All right, now they want us to write an equation for the area. How do you find the area for a rectangle?
WL.
Length times width. Okay, now, what's the only variable we want in our equation? W, which means we need to get rid of
L.
Good. Now, like on your test last week and on all the word problems we did last week, it was always, we were always replacing y. So we went and found something that said y equals 10 minus x squared, or the square root of x, whatever worked for us, okay? Now we need to find something to replace L with. This is the equation we want to use, the area, but this is the equation we've got to manipulate. So we need to rewrite the perimeter equation to get L by itself. Carly, to get L by itself, what would you move first?
Move the 2W.
So we have 2L equals negative 2W plus 400. And Will, how would you get L by itself after that? Well, it says 2 times L. Divide by 2. So you'd have L equals negative W plus 200. So now we'll take that and plug it in up here. So A equals, instead of L, we're going to write down negative W plus 200 times W. Excuse me. Distributing your W through, your area as a function of W would be negative W squared plus 200 W. W is the only variable in your equation, so that's when you're done. So we're still looking at replacing one variable with an expression. It's just that we had to get that expression on our own. It wasn't given to us. We had to rewrite the perimeter equation to get there. All right. So that is a quadratic equation. Part 2. For what value of W is the area largest? Okay, what's another word for largest? True.
Maximum?
Let's talk about a maximum, okay? If we want to find the maximum of that, how are you going to do it?
Plug it into a graphing calculator.
Get a graphing calculator. So we're getting a graphing calculator. And I believe this is a parabola that opens down.
Oh, thanks.
So Hagen, we can't type W, but what can we type? X. All right, so negative x squared plus 200x.
Oh, it's not on my graph.
Not on mine either.
Change your window.
Fix your graph.
You might try pressing zoom 0. What that does is at least finds part of your graph for you. You will still have to fix your window after that, but it gives you a good idea of which way you need to go.
Oh, that's
Okay,
crazy.
I don't think I'd do it.
2,256.
With the y max. But probably we need to go further to the right, I believe. So let's try 50.
What did it go?
Well, what do we do?
Can you see the top of the hill?
No.
So which way do you need to go?
To the right.
Okay, so then on your window, to go to the right, what are you going to change?
X max?
Good. I tried 50 and it was not far enough. So I'm going to try 150 now.
Well, now I can
I
sort
think
of
you
see
can't
it,
see
but
it
now I
when
need
it's
to go
regular,
up.
but you can see it when it's bigger. That's how it's wet.
You
No.
looked at it. Oh, you went to 200. Okay.
That's still not enough, and I went to 2,000.
Okay, so on my window, I made my X max 250. So going all the way to the right, 250. Cody, were you able to see yours? Okay. And then I went up on my Y max to 10,000.
Where did you have your X now?
Doesn't matter.
Oh, barely. Huh.
You should be able to see the top of the hill if you go up to 10,000. Well, you can make it
The
go
Y is
higher.
max 10,000.
Down mine, yes, that's what I used to get it to go up high enough. There we go. All right, so you are finding your maximum, so go ahead and do second trace for
Got it.
Cody. What did you get for your max, your ordered pair? Okay.
West Finger. I can't find my pointer back.
I got
Alright.
110,000.
Why is it so big?
What's in the negative?
Did you find it? There. All right, now, excuse me. Normally in an ordered pair, it's x comma y. Are we using either of those variables in this example? No. No, okay. What is in the x spot in our equation up here? What's in the x spot?
Wait, what? Oh, W.
W, okay. And what's in the y spot?
Okay.
A. Okay. So on this part 2, for our first example, for what value of W is the area largest? Well, what W value is that? 100, good. Now, that 100 is your width. What would the label on that be? Yards, good. And then on part 3, where it's asking what is the maximum area, what number do you use there?
Y?
Okay, in this case, what is that?
10,000.
10,000. The area is 10,000 yards squared.
So how'd you get that 100 and 10,000?
The calculator found it for us.
The 100?
The second trace 4, find the maximum. Yeah, isn't that what you got?
So that's how you
Yeah. Yours is being obnoxious.
She only has 400 yards of fence. That doesn't mean anything.
That's the
It's
area.
negative x squared plus 200x.
Wow.
We want to know the area, so you have to graph the area
It's
function.
inside the 400 yards.
It's the negative x squared. She's got 400 fence to go around it. It's asking what's the largest area that she can create using that 400 fence. Okay? If she wants to maximize her area, which usually is the point, then the width should be 100. Now, it's not up there, but if your width is 100, how do you figure out what your length should be?
Same. Probably.
No. Take
If
that
it's a
area-
rectangle,
Take that area, divide.
Yeah, okay. If you know that area is length times width, and you know that your area is 10,000, and that your width is 100, well, to get L, divide by 100. Yep, be 100. Okay. All right. Okay, there's that one. Moving on to example number 2. The sum of the squares of 2 consecutive integers is 61. Find the integers. If you're dealing with 2 of them, what do we always call the first one?
1 or X
X, and then what do we call the second one?
plus 1.
X plus 1. So our first number is X, and our second number is X plus 1, because we're dealing with consecutive integers.
If I can do it in my head, you show me to write everything down.
Yeah, because the point of this is to be able to create the model. All right, now, Mr. Crowley, what does the word sum mean?
Addition.
So we're going to be adding 2 things. It's talking about the squares of these 2 things. What would that look like?
X squared plus X plus 1 squared.
Good. X squared plus x plus 1 squared equals 61. All right, Easton, if you have a binomial and you square it, what does that give you?
Binomial.
All right, so if you take x plus 1 and square it, what does that give you?
X squared.
What's in the middle?
2x.
Good. This x squared out in front is still there. So, Lacey, if you have 1x squared plus 1x squared, what does that give you?
X squared.
Okay. So then we have 2x squared plus 2x plus 1 equals 61. Usually if we're going, you can do this in the graphing calculator, but this one isn't too hard to solve by hand. What do we like quadratic set equal to?
0.
0, okay, so pull that 61 over. We're looking at 2x squared plus 2x minus 60 equals 0. What can you divide everything by?
2.
2. So that gets us to x squared plus x minus 30 equals 0. Is it possible to multiply to be negative 30 and add to be 1?
Yep.
What would work?
So you got a positive 6, negative
X plus 6, x minus 5. So then what are our answers?
5. Negative 5. Or, yeah, 5 negative 6.
Good. Okay. Now, if we come back over here, if our first number is 5, what's the number after 5 going to be? 6. Okay, so one possible pair would be 5 and 6. If we started with negative 6, though, it would be negative 5. Good. So there'd be two sets of answers there. You solve, use both of the numbers, and then get the next number after them. Consecutive means right after it. Ashley, are you okay? All right. How you doing there, Will?
Good.
Mr. Lewis, are you all right?
Yeah.
Lacey, are you okay? Can I go to the next one? Sure. Mm-hmm. Go for it. Matt, when I find my test, what I did with the test, I'll give you yours back so you can see it. Okay, so on example 3, the lengths of the sides of a right triangle are consecutive even integers. Find these lengths. Drawing a picture can be very useful. This would be one of those instances. So what type of a picture should we draw? Draw a right triangle. Good. Now, if the sides are consecutive even integers, is this going to be an equilateral triangle? No. Okay, they're going to be. You're going to have a shortest side, a middle side, and then a longest side. Now, if they are consecutive even integers, what is called the shortest side? X. What would you call the other leg?
X plus 2.
And then the hypotenuse. X plus 4. Very good. Could you switch that and make x plus 4 on the leg and x plus 2 on the hypotenuse?
Has to be the biggest.
Good. The hypotenuse has to be the biggest one. Okay. Now, if you have a right triangle like this, what can you use to set up an equation?
It has to equal something, doesn't it? Does it have to equal 180 or anything like that, or no? Plus 2 equals x plus 4.
Not quite.
That's right.
You're close, though. Pythagorean theorem. A squared plus b squared equals c squared? Sound familiar?
Yeah.
Okay, so if we're dealing with the idea that a squared plus b squared equals c squared, what's in the a spot? X, so x squared, plus what's in the b spot? Squared, and then what's in the c spot? Good. All right, so Mr. Lewis, you had the right idea, it's just that they all have b squared. Alright, so x squared is x squared. Cody, if you take x plus 2 and square it, what does that give you? Good. Plus, I meant equals, sorry. Carson, on the other side, if you have x plus 4 squared?
X squared plus 8x plus 16.
Good. Okay. This is a quadratic. What do we like quadratic set equal to?
0.
0, alright. Would it be better to move the right side over to the left or take the left side over to the right?
Right side over the left.
Agreed, okay? If we bring an x squared over on both sides, that's going to be gone. So we'll have x squared minus 4x minus 12 equals 0.
You're out of tissue.
There's more on top of the pink filing cabinet there.
So
Alright, now.
6 and 2.
What, Cody?
Negative 6 and positive.
Okay, so x minus 6 and x plus 2. Factoring is a lovely thing. So we get x equals positive 6 and x equals negative 2. Do we want to keep both of those answers?
We always want the positive one,
Good, Matt. Why?
because it's distance.
We are talking about the length of a triangle here, so you can't have a negative length to your triangle. So we only want the positive number, so we'll go ahead and take 6. All right, so if one of our sides is 6, what's the next even number after 6?
8.
And then? So the lengths of the sides are 6, 8, and 12 units, because I didn't specifically give you a number there.
It should be 10, right?
10? Sounds better. Yep, good call. Let's go with 10. Sorry, I was thinking 8 plus 4. Yeah, consecutive, so 6, 8, 10. Good. Matt, you don't do corrections at all.
And why is it that you circled the 6?
Can you have a negative side to a triangle? That's why we only want the positive. Everybody okay with how we set up the picture?
Yeah.
Set up the equation diagram here. Okay. EC still awake? All right. Matt, are you okay with this one? Ready? All right, so let's take a look at this number 4. A bedroom is 3 feet longer than it is wide and has an area of 154 square feet. Find the dimensions of the room. A what?
Rectangle.
Let's do a rectangle. I agree. Okay. And what do we know about this rectangle?
3 feet longer.
The length is
Okay.
3, x plus 3.
So if I do an x plus 3 here, then what has to go on this side? Agreed. And then area is 154. Well, how do you find the area for a rectangle? And do we have a length?
Yep.
Do we have a width?
X plus 3, yeah.
So we have 154 equals x times x plus 3. Do we need to worry about like switching out a variable at all?
Set it equal to 0.
No, we'll just set it equal to 0. So we have how about 0 equals x squared plus 3x minus 154. That one's nice because you don't have to rewrite anything, plug anything else in. We're just good old factoring. And we are on example 4. So possible to multiply to be negative 154 and add to be 3.
Positive 14, negative 11.
Handy. Yeah, sounds good. Okay, so x minus 11 times x plus 14. So we have to choose between positive 11 or negative 14. Which one do we want?
Positive.
Agreed. So then, Cody, if x is 11, what would x plus 3 be? Good. Okay. So the dimensions of the room are, write it out, the dimensions are 11 what?
8,
By?
14 feet.
Good. Lacey, we went through that one pretty quickly. Are you okay with how we set it up?
Can you explain that?
Sure. Were you okay that x plus 3 and x are the sides of your rectangle and that the area is 154? So to find the area of any rectangle, you take the length times the width. So that's what this setup is right here. Length times width equals the 154. Okay? That is already a great equation. Like we don't have to replace either variable because we only have one. So distributing the x through, that'd be 154 equals x squared plus 3x. It is quadratic, and we let quadratic set equal to 0, so I pulled the 154 over, and that's where I got this line. And then factoring is really nice, and so that's what we did here. And then we picked 11 because you can't have a negative dimension to a room. Okay. So we kicked that one out. So over here, if x is 11, then x plus 3 would be 11 plus 3, 14.
Okay.
That's why. Ashley, you okay back there?
Mm-hmm.
All right. Okay. Cody, read that one out loud for us, please.
A piece of machinery is capable of producing rectangular sheets of metal such that the length is 3 times the width. Furthermore, equal size squares measuring 5 inches on the side can be cut from the corner so that the resulting piece of metal can be shaped into an open box by folding up the flat. And specifications call for the volume of the box to be 1435 inches cubed, which should be the dimensions of the original piece of metal.
What's one thing we know?
Needs to be 1435.
What does?
Volume.
The volume. Okay, so we're going to be talking about the volume of something, specifically the volume of a cube or a rectangular box. How do you find the volume of a rectangular box?
Length times width times height.
Thank you. Okay, so we know we're going to be dealing with volume equals length times width times height. Okay? And we know that the volume itself is going to be the 1,435 inches cubed. Are we starting off with a box?
Flat sheet.
We're starting off with a flat sheet. And what shape is that flat sheet? A rectangle, okay? So it's saying that you're starting with a rectangle. And what do they tell us about that rectangle?
Equal size squares measuring 5 inches on the side can be cut from the corners.
Even before that, they do give us something else.
Length is 3 times the width.
Good. Okay, so how would we put that down there?
X equals X 3X.
X and 3x. Good. Okay. All right. Now, equal side squares are going to be cut from each corner. Okay. So here, 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 and here, because they're cutting corners out of all four, cutting squares out of all four corners, and then they'll fold up the resulting pieces to make a rectangular box. And this is 5 by 5, and it's 5 by 5 on all of them. All right. Now, the width of our rectangular box, if we're cutting squares out of it, are we adding to it or are we subtracting? Subtracting. Specifically subtracting by what?
5.
10. Why 10, Matt?
5 on each side.
Good. You're taking a square out of each side, so it's actually going to be minus 10. So the width of this box is going to be x minus 10, because you're taking a square out from that corner and from that corner. Easton, are you okay with why we're subtracting 10? Okay. Now for the length,
3x.
again, we're taking corners out, so we're going to be subtracting. So it'll be 3x minus 10. Okay. So we've got our width, we've got our length, we still need that height. What do you think the height would be?
5.
It's 5, yeah, because that's what you cut out,
That's when they're folding up.
and that's what's being folded up. So when it folds up, it's a height of 5. All right, so in our formula, or excuse me, our volume equation, right up here, we'll say 1,435 equals, well, we've got parentheses 3x minus 10, parentheses x minus 10, and 5. Okay. Yes, we could solve this by hand. How else could we solve it, though? Put it in the calculator, okay? You can put everything over here, even parentheses and all, in your y2, and then the 1435 in y1. Now, in order to be able to see that 1435, you are going to have a rather big y max. But I'm pretty sure we were at 10,000 last time, so we should be okay. Neat.
Weird looking.
Mine looks like a parabola with a horizontal line through it.
Go grab one.
Good idea, yes. And well, you could do it by hand if you wanted to. Boil it all up.
It's easier to do by hand, I
Dingle?
think. I think I'd rather save myself even more of a headache than what I already have.
You're in good company. There's lots of headaches in here right now.
I just don't feel good.
The main one is math.
Misery loves company.
Plenty of that here, dear. Okay, that is roughly what my graph looks like. How many times does our parabola cross the horizontal line?
Twice.
Twice, okay? There is a negative answer and there is a positive answer. Do we care about the negative one? No, okay, so just find this intersection over here. You only have to do it once.
Which side?
Positive side. What the?
I got a decimal.
What do you say is your window?
Oh,
I did not. I got
Push zoom
I
zero.
got 17.
Zero?
And then you have to move it over a little bit, but it'll center you on the graph.
3x minus 10, x minus, oh, good call, guys. That should be a thing. You're right. I bet 17 is the correct answer.
What the heck just happened?
Okay, so you're fine. Go to your window. Come over here and make it 20, please.
This 20?
No, the max.
Oh, no. And then.
Graph. Cody, did you actually do it by hand?
Not even write it down.
You're looking for the intersection right here. So do your second, trace 5. And you want to find this one because we don't really care about the negative answer. Word problems, we almost never want the negative answer. All right, and then press enter 3 times. Good. Okay, that time I did get 17. All right. What should the dimensions of the original piece of metal be? If you've got x equaling 17, is that it? Like, are you done? No, what do you need to do with that?
The length and the width.
Plug it into your length and your width. Okay, so up here, in your width, if you do 17 minus 10, what does that give you? 7, okay. And then for your length, if you do 3 times 17 minus 10, 41. Huh? All right. Now, it's asking for the dimensions of the original piece of metal. What was the shape of the original piece of metal?
Rectangle.
It was a rectangle. So do we need to give the length, the width, and the height if they're asking for the original piece?
Just the width and the length.
Good, just the width and the length. Okay. So our final answer is that the dimensions,
Were.
agreed, 7 inches by 41 inches.
Would we have to add 5 on both of those though? Or 10 on both of them? Because.
Oh, snap, you're right. That would be better, wouldn't it? I did it for the, good call, Matt. We did it for the box, and we need to do it for the original.
51.
In fact, let's just go back to the original. If this is 3x, and you plug in 17 there, 51. Okay, and then 17. So the dimensions would be 51 by 17. Which, Matt, we would have gotten if we'd added on 10, like you said. Good call. Nope, we have an assembly.
Wait a minute.
Is that-
A saint
We
and
start that
sober.
hours, this and this hour.
Next hour, 7 hours. Not right now.
But I'm mathaholic.
Oh, wait,
I like,
Dylan, are you good with this?
Yeah, I
Like, you got everything done? Okay. Easton,
Yeah.
do you have anything done
Yes.
for example number 5? Okay. Matt, you good?
Mhm.
All right. Okay.
Word.
The floor of a one-story building is 14 feet longer than it is wide. The building has 1,632 square feet of floor space. Part A, draw a visual representation of the floor space. Represent W as the width and show the length in terms of W. So what are you going to draw?
A box.
Maybe not.
Rectangle.
Just a rectangle. Because it's just talking about the floor
A
space.
box can be rectangle. Flat box.
That's what we'll talk about, a flat box.
Okay.
All right, Mr. Kirby, what do we know about this box?
Not good.
14 feet longer than it is wide.
Okie dokie, so what are you going to do there?
X plus 14 on an
Which variable do they want us to use, though?
W.
W, okay, so we'll use W here, and then if it's 14 feet longer than,
plus 14
W plus 14. There we go.
and W on the side.
So if we don't use one variable in our work, but we get the right answer, what would happen? We'll be fine.
If you use X throughout the whole thing, that's fine, but if you like jump back and
Switch it.
forth between X and W when they're supposed to be the same thing, that's when it's a problem. Okay.
Do we have to put 16, 32?
Huh? Now, what should we do with that 1632? That's the area, okay? So in the middle of the box, we'll write A equals 1632. On part B, write an equation in terms of W. Well, what kind of equation could we write?
1632 equals, and then looking times W and W plus 14.
Length times width. W times W plus 14. And make sure it is in parentheses. You can leave it like that, or you can distribute it through. Either way is good. So 1632 equals W squared plus 14W. All right, now find the dimensions of the building floor.
Equal that to 0.
Set it to 0, agreed. So W squared plus 14W minus 1,632 equals 0. My chart does not go up that high. Try factoring. Figure out what multiplies to 1632 and adds to 14.
Adds to be 14?
I believe so,
You
yeah.
can find that in there. Breaking for a cube.
Possibly.
Oh, I got it to be 19, not 14.
Those numbers are too high for me.
Okay, then do quadratic formula or put it into your graphing calculator.
That's what it is.
14 doesn't seem big enough. Maybe it's just me, I don't know.
We'll either start guessing and checking, or put it into your graphing calculator, or use the quadratic formula.
If we graph it, does it just fill it?
That's one where you look for the intersection. So yes, it will tell you,
How does
but
it
you have to know how to,
Oh, yes, you
Work
use
it.
brain.
you have to be able to find it.
How come the graph and date answer to? That doesn't make any sense.
A graph is just the visual representation of
34.
the math. I got 34 as well. Yep.
We're ruining it.
Okay, so I did mine via the graphing calculator, and I got W to equal 34. Okay. Is that enough? Are we done with this problem? No, that's the width. What do we still need?
Length.
The length. Okay, so over here, if our width is 34,
Add 14 to it.
and that would give you, how about 48? Okay. Alright, so the dimensions are 34, what's our label on this?
Feet.
Ah, thank you. By 48 feet. There we go. All right, that seems like enough for today. So you have a worksheet.